In problem 1, this is a recap from the ideas we learned in A0. For the function f of x equals negative x squared plus 5, it says determine the following. Part A, the slope of the secant line from x equals 1 to x equals 3. So when you want to calculate a secant slope with specific values like this, right, we use the average rate of change formula. And the average rate of change formula is f of b minus f of a over b minus a. So rather than just diving right into this formula directly, it may be helpful to calculate each piece before we plug it into this formula. So the first thing that I want to do is my b is going to be 3. So x equals 3. And I want to calculate f of 3. And so in my formula, everywhere I have an x, I'm going to plug in 3. So I get negative 3 squared plus 5. And so this is 9 times negative 1. So I get a negative 9 plus 5. And this gives me negative 4. For x equals 1, 1 is our a value, right? The first part of our interval. So we're going to evaluate f of 1. So just like before, everywhere I have an x in my original formula, I'm going to plug in a 1. So now I can see that 1 squared is 1 times negative 1 gives me negative 1, plus 5 gives me positive 4. So now when I evaluate this into my function, I can say that this is my, right, f of b, this is my f of a. So now I've got negative 4 minus f of a, which was 4, all over b, which was 3, minus a. So when we compute this, I get negative 8 in the numerator, 3 minus 1 is 2, and negative 8 divided by 2 is negative 4. So there is my secant slope. Now we want to know, well, what is the slope of the secant line from 1 to 1 plus h? So this is where I was saying it might be helpful to actually kind of scaffold our algebra, sort of do as much of it as we can before we set up our formula. So the first thing I'm going to do is I'm going to find what f of b is. So this, in this case, b is 1 plus h. So f of 1 plus h is negative 1 plus h squared plus 5. So I'm going to go ahead and expand this out. So I'm going to FOIL first. So I'm going to leave the negative alone. And when I multiply this out, I get 1 plus 2h plus h squared plus 5. And now I'm going to combine like terms. So I have a negative 1 plus 5 is 4. Negative times 2h, negative 2h, and a negative times h squared. F of 1 I actually calculated in the previous problem, and I already know that that's going to work out to be 4. So now when I set up my difference quotient, I'm going to have f of 1 plus h, 1 plus h is also going to be here, minus f of 1, right, over 1 plus h minus 1. Now I can substitute in each of the pieces I've already calculated. So f of 1 plus h was 4 minus 2h minus h squared. I'm going to then subtract f of 1, which was 4, and the denominator, 1 plus h minus 1, the 1's actually become 0, and so all I have in my denominator is just h. So now I'm going to try to combine like terms in the numerator. So 4 minus 4 add up to 0. So every term in my numerator has an h, so I'm going to pull that out front, and I'm left with negative 2 minus h all over h. The h's in the front here cancel, and I'm left with negative 2 minus h. Part C says, well, what's the tangent slope at x equals 1? So the tangent slope is the same thing as saying calculate the derivative at 1. So f prime of 1 is the limit as h goes to 0 of f of 1 plus h minus f of 1 all over h. We actually computed the difference quotient here in the previous part. So I can say, well, this is now just evaluating the limit as h goes to 0 of negative 2 minus h. So this can be done through direct substitution. I plug in a 0 for h, and I get negative 2 is the tangent slope. Part D says we'll now write the equation of the tangent line to the graph at x equals 1. So our point that we're going to use for our point slope formula is 1 comma f of 1, which was 4. The slope of our line is going to be f prime of 1, which we just found to be negative 2. So now, if I want to start with my point slope formula, I can fill in all the required pieces. So y minus 4 equals negative 2 times x minus 1. And I can actually stop right here. That is, in fact, the equation of the tangent line.